Plate tectonics. Essential question. What are the different plate boundaries and how do they cause changes to the Earth's surface? Go ahead and write that on your paper where it says essential question. We're covering 3 standards here. The first standard says connect surface features to surface processes that are responsible for their formation. Second one says analyze the scientific theory of plate tectonics and identify related major processes and features as a result of moving plates. And the third one says describe the geologic development of the present-day oceans and identify commonly found features. Bellringer. During the last 50 million years, the lithospheric plates carrying modern-day India moved towards its present position. As it moved, the Himalayan mountains were formed along the boundary of the Indian and Eurasian plate. Which is the best answer to explain the type of movement between these plates? A, the 2 continental plates move past each other. B, the 2 continental plates move towards each other. Or C, the 2 continental plates moved away from each other. And D, the continental and oceanic plates moved towards each other. So the best answer would be B, the 2 continental plates moved towards each other. When the 2 plates came together, they formed a mountain. What moves the plates? The crust is the hard, rigid, thinnest surface layer. Continental crust is land. Oceanic crust is the ocean floor. The mantle is the layer below the crust. The lithosphere is where the magma meets the crust. So this is the lithosphere right here, this very thin layer. The asthenosphere is the hot magma that's plastic-like. And convection currents in the magma in this layer make the plates move. So you can see right here they have convection currents, and these are what is causing the plates to move. They have up here trenches. You can see slab pull where it's pulling it down here. It's going under the other plate. We have a ridge here, a trench over here. The outer core is hot liquid layer that surrounds the inner core. It's made of an iron-nickel mix. The inner core is hot, very dense. It's the center of the planet. It's under very high pressure and it's solid. Again, that's made of iron and nickel mix. And you can see the picture here where it has the inner core, the outer core, the mantle, and the very top is the crust. What is plate tectonics? The theory of plate tectonics states that the Earth's crust is broken into a dozen plates that are moving relative to one another as they ride atop the hot, plastic-like mantle. The entire Earth's surface is continually shifting. Convergent boundaries. Continental plates is 2 continental plates collide. The results are mountain building and earthquakes. Examples are the Himalayan mountains and the Appalachian mountains. Continental oceanic is 1 continental plate and 1 oceanic plate meet, and the more dense oceanic plate gets pushed under. It's called subduction. Just think about a submarine goes under this continental plate. Examples, ring of fire, and results are volcanoes and earthquakes. Oceanic is where 2 oceanic plates meet. The denser plate gets pushed under the other, and the result is volcanic islands like the Hawaiian Islands and earthquakes. You can see here how the oceanic crust is going down underneath the continental crust because it's more dense. Volcanoes are forming here. Convergent boundary examples. Each red dot is an active volcano. The Pacific plate is slipping under the Eurasian plate, North American, and Indo-Australian plates. So you can see we have a lot of volcanic activity here in the ocean and along the coasts. Divergent boundary is where tectonic plates are moving away from each other. Magma rises and new crust is added. The results have mid-ocean ridges, underwater volcanoes. Just think about that book, The Divergent, where they separated them out into different groups. And in the middle here, where this crust is forming, this new crust, so this part of the ocean floor is newer. And as you go along, the crust gets older and older. Transform boundaries are where two plates move or rub against each other in opposite directions. This creates pressure that is released when the plates move suddenly, and the results are earthquakes. Example, San Andreas Fault along the California coast. If you were using Oreo cookies, you could have a plate sliding over the asthenosphere. Divergent was where it's coming apart. Convergent, you're pushing it together. And transform, it's sliding past each other. And if you slid those past each other, you would see that some of the crumbs would break off. You can model the plate movements with your hands. So using your hands, you can model convergent, so they're coming together. Divergent, they're moving apart or dividing. And transform is sliding past each other in opposite directions. You're going to fold your paper in half, and on the inside, you're going to answer the 4 bell ringer questions and complete the exit ticket. So I'm not going to read the bell ringer questions to you. You can go through and read those on your own. You're going to answer these. There's 1, 2, 3, 4. And the exit ticket says, what are the different plate boundaries? And how do they cause changes to the Earth's surface? There's a typo here. It should say how do.